Next lesson in Unit 4 is titled The Distributive Property. Our standard is 7AF1, being able to apply the properties of operations to create equivalent linear expressions. So that will include the distributive property and being able to justify your steps. So the vocabulary term today is equivalent expression, and an equivalent expression are expressions that have the same value. So when we are simplifying or distributing, the expression that you create is still equal to what you started with. This slide is all dedicated to the distributive property, its definition, and some examples. So this all needs to be in your notes. But when you do the distributive property, you are multiplying a sum or a difference by a particular number. You will multiply every term inside the parentheses by the number that's outside the parentheses. So you can see in the two general examples here, we have A times the parenthesis of B plus C. Well, that's the same as doing A times B, which you see there, and then doing A times C, which you see here. So you're multiplying everything on the inside by what's on the outside. It also works if there's subtraction inside. So first you do A times B again. That gives you AB. And then you multiply the A times the C to get AC. Now remember that subtraction really just makes the number behind it negative. So we bring the subtraction sign along with us because it's really saying A times a negative C. And A times a negative C would be a negative AC, which means we subtract. Here are some examples using actual numbers. 5 times 6 plus 7. And I'm just showing you the distributive property. We're not going all the way through and evaluating. But you would do 5 times 6, which you see here. And then you would do 5 times 7, which you see there. And the next example looks a little different because now we have the number behind the parenthesis, but it still indicates multiplication. When you do it this way, please still multiply by the first number in the parentheses first. Notice I have 9 times 8. And then 8 times that negative 3. So we bring that subtraction sign along with us because that would be a negative 24 or minus 24. You can simplify these further, which is what we'll do in our homework and in the notes here in a moment, but 5 times 6 is 30, 5 times 7 is 35, and 30 plus 35 is 65. Now some of you might be saying, but hey, order of operations says I need to do the parentheses first. And that is true. With order of operations, it does say do the parentheses first, but I'm showing you that the distributive property will also get you to the same answer. And later on in the lesson when we start working with variables, it won't matter because you won't be able to add what's inside the parentheses. So if we did it the old-fashioned way, let's go over here. If we did it using order of operations, I would have 5 times 6 plus 7. That would be 5 times 13, and 5 times 13 is 65. So you can see that you still get the same answer. In your homework, though, I will specifically say use the distributive property, which means we need to be doing it this way we have over here on the left. So here are some examples. Again, it does say to use the distributive property. So you're doing 5 times 12 plus 5 times 4. 5 times 12 is 60. 5 times 4 is 20, and 60 plus 20 is 80. So the equivalent expression is this 5 times 12 plus 5 times 4. We are evaluating it then by doing our multiplication first and then our addition. So I'm checking two steps. I'm checking for this step and I'm checking for this step. On example 2, again, the 8's in the back, which doesn't really matter. but we still want to work from left to right inside the parentheses so we don't mix up our signs. But it's 8 times 21st minus 8 times 3. And you can use parentheses if you'd like, or you can use the dot for multiplication. 8 times 20 is 160 minus 8 times 3 is 24. So 160 minus 24 is 136. So again, I'm looking for this step. That's the equivalent expression, and I'm looking for that step. If you'd like to pause the video and try these two on your own, we do 4 times 6 and then 4 times 3. So 4 times 6 plus 4 times 3. There's your equivalent expression. It means that it's equal to what you had in the original problem, and it's 24 plus 12. 24 plus 12 is 36. The next example, 4 times 9 minus 4 times 2. There's your equivalent expression, which becomes 36 minus 8, or 28. Oftentimes with the distributive property, it allows you to do some mental math a little bit faster. So the example here is that 4 times 37, doing that problem in your head can prove to be a little bit tricky, especially if you get to even bigger numbers. But you can evaluate using the distributive property, so we can break up 34 into 30 plus 4, and it makes the problem a little simpler. Most of you could tell me pretty quickly that 7 times 30 is 210, and 7 times 4 is 28. Then if you're adding 210 to 28, you get 238. It's a little bit harder in your head to be multiplying 7 times 34 and be thinking, okay, 7 times 4 is 28, carry the 2, write the 8, then you have to do 7 times 3, add 2. So that can just be a faster way to do some mental math using the distributive property. So an example here, and it doesn't specifically say to use the distributive property, but we're going to. So on a school visit to Washington, D.C., David and his classmates visited the Smithsonian Air and Space Museum. Tickets to the IMAX movie cost $8.95. Find the cost for 20 students to see the movie. And this can actually be done a couple of different ways. So 20 students, if you look at the price of the ticket, it's almost $9. It's actually $9 minus 5 cents. And we're going to use the distributive property. Let's say we didn't have a calculator. We're going to multiply that by 20. Hopefully you agree that $9 minus 5 cents is $8.95. So that is the ticket price times the 20 students. But it's a lot easier to do 20 times 9 and 20 times 0.05 than it is to do 20 times $8.95 in your head. So if you have $9 tickets and you're buying 20 of them, that's $180. So I'm going to write out here the equivalent expression. But we have to subtract out that extra 5 cents for every ticket. So 20 times 9 is 180. And if you're doing 20 times 5 cents, that's $1. 180 minus $1 is $179. So again, using the distributive property, and if you were going to just round or estimate, you might have said, well, it's close to $9, 20 times 9 is 180, so it's about $180. But if I want to know the exact amount, let's say I have to take a check with me or something, then we have to subtract out that 5 cents for every one of those tickets. So the distributive property comes in helpful when you're estimating. Now we're going to add in some variables. So the distributive property, writing each expression as an equivalent algebraic expression. We're using the term algebraic now because we're going to be adding in variables. So nothing changes here. It's still The number on the outside multiplied both pieces on the inside. So 4 times x plus 4 times 5. 4 times x is just 4x. 4 times 5 is 20. And now you're left at a place where you can't do anything else because these are not like terms. So we can't combine them. You don't get 24x here. So 24x, that doesn't work. Because the 20 doesn't have any x's on it, you cannot add it to the 4. So this is your answer. I'm also going to throw in a secret word here, so please write this into your notes so that I know you're listening. The secret word is Halloween. Example 7, we're going to distribute the 6 through the parentheses, so it's 6 times y plus 6 times 10. 6 times y is 6y. 6 times 10 is 60, and again we cannot combine these terms because the 60 doesn't have a y attached to it. This is your final answer. This is the simplified algebraic expression. If you'd like to pause the video and try these two on your own, I'm going to incorporate some subtraction. We're still on number 8, multiplying the 3 times the variable m and then 3 times the 4. Paying attention that that subtraction sign is there. So 3 times m minus 3 times 4. 3 times m is 3m. 3 times 4 is 12, so it's 3m minus 12. Number 9, we're going to have to be a little bit careful because the 9 outside is negative, so it's negative 9 times n minus, and I'm going to put this negative 9 in parentheses so I don't forget about it, negative 9 times 7. Well, negative 9 times n is just negative 9n. Minus negative 9 times 7 is negative 63. We don't write our answer like this. We don't say minus a negative. So we do need to take that one step further. Negative 9n plus 63. Remember, subtraction, we add the opposite. So it becomes negative 9n plus 63. This is an e-learning video. If you're watching this and it's not an e-learning lesson, we'll work on worksheet 4.2 in class. But since it is an e-learning video, you will also have the worksheet to complete for e-learning. In the past years, this has been an e-learning video sometimes, and other times it isn't. So if this is an e-learning video, you should also be completing the 4.2 practice worksheet. And if it's not an e-learning video, then we'll do 4.2 in class.